Let's go ahead and find the force on this dam wall. Well, the acronym that we use for force on a dam wall is the integral of ADD area. And by area, we do not mean the area of the wall. We mean the area of the following. So first we imagine a horizontal element here, and then we imagine some thickness to this horizontal element. So it's essentially a horizontal rectangle. The thickness of that horizontal rectangle is dy, and the width of that horizontal rectangle is w. And the area that we're referring to is the area of that thin little rectangle. So that will be w times dy. That is the area that we're referring to, the elemental area. Let's go ahead and replace these letters here. So A is acceleration, the first D is density. Density of water is 1,000. And the second D. The second D is the distance below the surface, or the depth. And because this dam is 3 tall, this will be a 3 minus y. So that's going in here. And that's going to be multiplied by w, multiplied by dy. Again, w dy is the area. Limits of integration, we have horizontal elements of water from 0 up to 3 meters. So we have that. Now the hard part, we need to figure out the value of w as a function of y. So what we need to do is figure out the equation of this line here. So we need those 2 points. Well, this point here is 1, 0. And that point over there will be, let's see, 2, 3. This will generate a slope of 3 minus 0 over 2 minus 1. So this slope is 3. We can then use the point slope formula, which I will use with this reference point. So y minus 0 equals the slope times x minus 1. So y will equal 3x minus 3. Now that is presented to us as a y value, so it's measuring heights. That's not what we want. We want to measure horizontal here. We are trying to measure the horizontal distance right here. So we want to isolate x so that we are measuring horizontally. So there is x. Now that is not w, right? That is not w. W is 2 times this x value. So in other words, w is 2/3 times y plus 3. And that will drop into our equation over here. So let's clean this up a little bit. So 9,800 to the front. So that's this part right here factored to the front. And then we are going to have the 2/3 also factored to the front. So that 2/3 is coming from w right there. That's coming to the front. And then we have 0 to 3. We have the 3 minus y. And then the part of w that's left is y plus 3. And then we have our differential. So there is our formula for force. Let's go ahead and we'll just leave these constants as is for now. Maybe something will simplify in a bit. So the inside of this integral will become negative y squared plus 9 times dy. The inner and the outer are going to cancel there. So let's come up here. We will have 9,800 times 2/3. And then we're going to integrate. We will get negative y cubed over 3 plus 9y. And the limits of integration there will be 0 to 3. Plugging in 0 does not contribute any force, so we can ignore the 0. We will have 9,800 multiplied by 2/3 multiplied by, let's see, when we substitute in the 3, We get 27 over 3, which is 9. So we have negative 9 plus 27. And once again, plugging in 0 gives 0, so that's gone. So this will be 9,800 multiplied by 2/3 multiplied by 27 minus 9, so that's 18. This 3 will go in there once and go into there 6 times. So we'll have 9,800 times 12. 9,800 times 12 will be 117,600. And units of force are newtons. So that will be the force on the damn wall.